Today we're going to have a look at fractions being divided by integers. Now you should remember that integers is another word for a whole number. So we're going to have a look at this here. So 6/7 divided by 2. So the first thing that I want you to do is draw yourself a bar model. So I have a bar model here. That's my whole rectangle. I split it into 7 parts because that's my denominator. Now if we're looking at 6/7, the first thing I'm going to do is shade in 6/7. So I'm going to shade 1, 2, 3, 4, 5, 6 out of the 7 are now shaded. Now the next thing it's asked me to do is divide this by 2. So we know that if we're dividing by 2, we're sharing it equally between 2 groups or 2 people. So if I was splitting this between 2 groups, I would have 2 groups here. Now I can see that in each group I have got 3/7. Now when you were at primary school you may have been taught a slightly different method. I'm going to show you that now and then you can see what that relationship is with this. So you may have been told that 6/7 divided by 2, and we know that 2 is the same as saying 2/1 because 2/1 is 2 divided by 1, which is still 2. Then you may have been taught something about keep, change, flip. So we would have kept this bit the same, changed that bit to multiply and flipped this last bit. And then you would have multiplied across the top. 6 multiplied by 1 gave you 6. Multiplied across the bottom, 7 multiplied by 2 gives you 14. Now you may be saying, well, hang on a minute, they're not the same. But remember, we can use equivalent fractions. So I know both of these are even numbers, so they can definitely be divided by 2. So 6 divided by 2 gives me 3. 14 divided by 2 gives me 7. And I end up with the same answer. Okay, now what I'd like you to do is pause the video and I would like you to have a go at these questions. I'm just going to put up on the board for you. So 3 questions for you to have a go at. Now while you're doing this, I want you to have a look at what do you notice about this one and this one. So the first 2, what patterns are you seeing? Jot down any patterns that you do notice. And then with this third one, something's different about this one. I want you to see if you can spot what's different and how we might be able to deal with that. So pause the video, go give them a try. Once you've done that, you can come back and we can go through the answers together. Okay, so let's have a go at these. So the first one, it was 6/7 again, so let's highlight that. So we've got 1, 2, 3, 4, 5, 6. So you should have that drawn out in your books. Now this time we're dividing it into 3, so we want 3 equal groups. So I know that I could go 1, 2, 3 equal groups. Oops, bit off there. Each group has got 2/7. Okay, now the second one. We've got 4/7. So again, the shape is split into 4 parts. I'm going to highlight 4 of them. Now we're going to divide this by 2. So if I'm dividing it by 2, I'm splitting it into 2 equal parts. So 1, 2. In each one, we can see that there is 2/7. What do you also notice with this one? Now it's the same, we're looking at half of it. So actually this is the same as saying 4 over 7 multiplied, let's write that, 4 over 7 multiplied by 1/2. Now hopefully you're starting to spot the pattern with what I showed you on the previous slide. So now this last one, were you spotting anything? Well, what you should have noticed is here we were doing 6 divided by 3. Now we can divide 6 by 3 quite easily and still get a nice round number. But here we're doing 4 divided by 3, so this is going to make it a little bit more difficult for us. So there is definitely going to be another step involved in this. So let's start by highlighting 1, 2, 3, 4. Okay, so now if I was going to split that into 3 equal groups, I could definitely say, well, 1, 2, 3. So I've got 1 in each group, but then this one I'd have to split into 3 parts. So 1, 2, 3. Now you can see where this is getting a little bit more complicated. So I could argue, well, there's 1 and 1/3 over 7. So 1 and 1/3 sevenths. So something should be ringing alarm bells to you at the moment. So absolutely, we can't have 1 and 1/3 over 7 because that wouldn't be a proper fraction. So we're going to have a look at how we could change that. So what could we do using our prior knowledge of fractions? We could have a look at an equivalent fraction. So I know that thirds, I can multiply that by 3 to get a whole one. So let's have a look if I multiply the whole lot by 3. I know that 1 multiplied by 3 will give me 3, and a third multiplied by 3 would give me the 1. If I put them together, I'm going to get 4. And then 7 multiplied by 3 is going to give me 21. Now that gives me a proper fraction, and it is equivalent. Now remember our other method that we looked at on the previous slide? You could use that here. So you could say, well, 4 over 7 divided by 3, and remember we can put 3 over 1 because it's the same as writing 3. Now we already said that with our keep, change, flip, we could rewrite this as 4 over 7 multiplied by 3. Oops, sorry. Multiplied, and now we're going to flip this bit and do 1 over 3. Now you can see why this was the same here. We looked at this pattern, didn't we? How dividing it by 2 was the same as multiplying it by 1/2. And here, dividing it by 3 is the same as multiplying it by 1/3. Now remember, we can now multiply across the top. That would give me 4. Multiply across the bottom, 7 times 3 would give me 21. So hopefully you can see why these two methods work, and also spot when the method is useful here or when you may need to consider a slightly different method to use.